Hey everybody, welcome to another video. This one's on Introduction to Functions version 2. So if you're in my class, you had this sheet given to you and you had to work with it. If you're not in my class, obviously, then you're just watching this. So a couple things to pay attention to here. The first function sheet that we had, Introduction to Functions version 1, is basically we had to guess the rule. So let's just practice that again. So in this case, we're inputting a 1, outputting a 4. So something's happening to that 1 inside here that's creating it to be a 4 when it comes out. So what are we doing mathematically to that 1 to make it into a 4? Is it plus 3? Is it times by 4? Is it something different? So we input a 2. Now all of a sudden we're outputting a 9. We input a 3, outputting a 14. What's happening inside this box, right? So we got to figure out what's actually occurring inside the rule box here, right? So there's a couple ways to do this. Hopefully you guys have figured it out already, right? If you haven't, no big deal. First thing you do is check to see if the ratio is always the same. In other words, is it a proportional relationship? What would I multiply 1 by to get 4? 4. So 1 times 4 is 4. Is 2 times 4 8? Yes, but is it 9? No. Right? So we can see that this is not a situation where it's proportional because 4 over 1 is not the same as 9 over 2. Right? 4 over 1 is 4. 9 over 2 is 4.5. So we can see it's not proportional. The next thing you would look at is to ask yourself, is it linear? Now, linear just means it has a constant rate of growth. So if we're looking at this situation here, we ask ourselves, how is the output changing as the input changes, right? So what's the change in y, and how does it relate to the change in x? And this is called the slope. So slope is just going to be the formula change in y, delta y, over change in x, delta x. So in this case, we can see that the output's changing by 5. Right, 4 plus 5 is 9, as the input changes by 1. So 1 plus 1 is 2. So we can see that the first slope ratio that we have here on this function, if it is a line, would be the ratio of 5 over 1. We have to ask ourselves, is that growth ratio staying the same? So when we look from 9 to 14, what's the change in outputs? Once again, it's plus 5. From 2 to 3, what's the change in inputs? Plus 1. So the ratio, change in output over change in input, change in y over change in x, is still 5 over 1. So it looks like that's a consistent ratio of growth, right? That every time the input is changed by 1, the output seems to be changed by 5. As x increases by 1, y increases by 5. So that tells us this is a linear function. Now, every linear function is going to be in the form, or can be written in the form, y equals mx plus b, where m is the slope or the growth rate like we just discovered, and then the b value, what you're adding or subtracting here, is what we call the y-intercept, where a line crosses the y-axis. So in this case, we're looking for a rule that's going to be in this form, y equals mx plus b. And we know that the m is 5 over 1. So we know that we're going to start with that idea. So it's going to be y equals 5 times x. Now, obviously, if it was just 5 times x, then we'd be done. It'd be proportional, right? 1 times 5 is 5, but it's not. 1 times 5 is 5, but the answer should be 4. So what's the adjustment that's happening here? How do we change that 5 into a 4? Well, what would you add to 5 to make it 4? You'd add negative 1. So it looks like the rule might be y equals 5x minus 1, where the y-intercept is that negative 1. So this line's basically been shifted down 1 unit on the y-axis. So instead of crossing at 0, 0, it crosses at 0, negative 1. So let's see if that rule works. 2 times 5 is 10, 10 minus 1 is 9, yes. 3 times 5 is 15, 15 minus 1 is 14, yes. So it works for the entire table, so it is a function that's working appropriately. And so 4 times 5 is 20, minus 1 is 19 would be the last value here. So if you're given a mystery rule where you don't have the rule, this is the process you might use to discover the rule. You'd first check to see if it's proportional, then you check to see if it's linear by investigating the slope. But in most of this paper here, what we're going to get is something where we're given the rules. So once you are given the rules, all I really want you to do with this is I want you to fill in the output table, describe it, and analyze it. Okay? So let's go through and do the process real quick, and let's see if you guys are getting the idea. So here, you're going to obviously always multiply before you add. So when you insert the x, you're going to just times it by 2 and then add 3. So let's do it. All right, let's practice. 1 times 2 is 2. 2 plus 3 is 5. 2 times 2 is 4. 4 plus 3 is 7. 3 times 2 is 6. 6 plus 3 is 9. 4 times 2 is 8. 8 plus 3 is 11. So we filled out our table. We can see this rule is in the form y equals mx plus b. So that's the standard form of a line called slope-intercept form of a line. And that means that the 2 is the slope, right? It's the slope ratio. And in case you're wondering what it means, that 2 there basically means as the output changes by 2, the input changes by 1. So as x increases by 1, y increases by 2. That's what it means. And then the plus 3 basically means the y-intercept is 3, and that is where the line crosses the y-axis. So this line will cross the y-axis at the order pair 0, 3. That is the place where the line will start on the y-axis. It's called the y-intercept. So you have this idea of the slope in blue, which is the change in y over the change in x, and this idea of the yellow value being the y-intercept, where the line crosses the y-axis. So this is a straight line that crosses at 0, 3, and then goes up in a ratio of 2 over 1, so over to the right, 1 and up 2, as it moves along the line. So that's how it goes. And we can describe this as a non-proportional linear function. We know it's not proportional because it doesn't cross at 0, 0. Remember, a proportional line is a straight line that crosses at the origin, 0, 0. If it doesn't cross at the origin, or it's not a straight line, it's not proportional. So this is a non-proportional but still linear function, right? It's a function because for every x, there is only one y. So every time you put a 1 in, you're going to get a 5 out in perpetuity, forever, right? So this is only going to give you a 5 output every time you put an input of 1. Now, can you have situations that are functions where the same output occurs for different inputs? Yes. But what you have to make sure for a function, you have to make sure that for every input, there is only one predictable output. So for every x value, you have one y value. Every time you put that input in, you get the expected output out. All right, so that's kind of the explanation of all this. Let's see if the next one's easier now that we've kind of talked about the big principles here. Once again, this is going to be y equals mx plus b, slope-intercept form. So once again, when we describe it, we're going to say this is a non-proportional linear function, and in the form y equals mx plus b. We know that it has a slope of 1/2 and it has a y-intercept of 6. Okay, so when we describe it, if we're talking about fully describing it, we would say that this particular line here is going to have a slope of 1/2, and it's going to have a y-intercept value of 6. So 0, 6 is where it crosses the y-axis. Okay, and that's it. We know that to be true, right? Because it's in the form y equals mx plus b, where the multiplier for x is the slope, and the addition or subtraction element is going to be the y-intercept, where the line crosses the y-axis. So this is your m, right? This is your slope, and this value here is your b, your y-intercept. Okay, now we can plug in and just kind of solve it. So let's do that. So we're going to multiply by 1/2, which is basically divide by 2, and then add 6. You always multiply before you add. So 1/2 of 2 is 1, 1 plus 6 is 7. 1/2 of 4 is 2, 2 plus 6 is 8. 1/2 of 6 is 3, 3 plus 6 is 9. 1/2 of 8 is 4, 4 plus 6 is 10. And as we described the idea of slope, what you can see here is that the same thing is happening, that if you were to add 1 on the y, you're going to be adding 2 on the x. So that means every time you increase the x by 1, you're increasing the y by 1/2. Okay, which is why the multiplier is 1/2. Okay, let's go to the next problem. So the next one here is another situation where we're given the rule. This is negative x plus 2, so y equals negative x plus 2. Basically, take the x value, make it its opposite, and then add 2 to it. So 1 times negative 1 is going to be negative 1. Make it its opposite, so it's negative 1. And then you're going to add 2. What's negative 1 plus 2? Negative 1 plus 2 is positive 1. Opposite of 2 is negative 2. Negative 2 plus 2 is 0. Opposite of 3 is negative 3. Negative 3 plus 2 is going to be negative 1. Opposite of 4 is negative 4. Negative 4 plus 2 is going to be negative 2. All right. And as you can see, this is another line in the form of y equals mx plus b. This time the slope is going to be negative 1 and the y-intercept is going to be 2. So when we describe it, we'd say this is a non-proportional linear function because it doesn't go through the origin, right? It goes through a different point than that. It goes through 0, 2 as its intersection with the y-axis. And it's still a linear function because the slope is still a constant value, right? The change in y over change in x is always the same throughout this table. And we can write down that the slope of this particular line is going to be negative 1. And we can also say that the y-intercept for this particular line is going to be the order pair 0, 2, right? In other words, the y is a value of 2. It crosses the y-axis at 2. This one here has no plus or minus, so this is just y equals 3/5 x. This is an example of a proportional relationship, because when x is 0, y is also 0. All right? So this is going to be not a non-proportional, but a proportional linear function. It is still a straight line that goes through the origin. So we're going to just plug into this. When you are doing this, the easiest way to multiply by 3/5, in my opinion, is to first ask yourself how many times does 5 go into our input, and then multiply by 3. So really what you're doing here is you're saying the y is equal to 3/5 times our x value over 1, right? And because of that, we can really look to cancel the 5 out with whatever our input x value is, and then multiply by 3. So let's do that. So 5 goes into 5 one time. 1 times 3 is 3. So 5 goes into 10 two times. 2 times 3 is 6. 5 goes into 15 three times. 3 times 3 is 9. And then 5 goes into 24 times. 4 times 3 is 12. So that's kind of how we'd set this up. Now in this one, are you going to have a y-intercept? Yes, the y-intercept happens to be 0, 0, just like the x-intercept is 0, 0. This is a situation that's proportional, so it crosses the origin 0, 0. But you could still describe the slope on this one. The slope is just your k value, or your constant proportionality. So in this case, the slope of this line is 3/5, right? As x increases by 1, y increases by 3/5 every single time. Let's take a look at the next one. This is once again another proportional relationship, y equals 8x. So we can write that in. This is a proportional linear function. This is going to go through the origin because when x is 0, y is also 0. So we have a proportional linear function. This one's really easy. 1 times 8 is 8, 2 times 8 is 16, 3 times 8 is 24, and 4 times 8 is 32. Now, if we described it, we could say that the slope of this particular line is a value of 8, right? As x increases by 1, y always increases by 8. Okay, this is in the form, by the way, just so you can be clear on remembering it, y equals kx, where k is your constant of proportionality or your slope. In this next one here, we got y equals mx plus b again. So this is going to be a situation where you have a non-proportional linear function. So this is, once again, non-proportional because it doesn't go through the origin. Linear function because it has a constant rate. Every time x increases by 1, y increases by the same predictable amount. And it is a function because for every x, there is only one y. And so let's do that. We're going to write in our slope value here. Our slope value of this one is the coefficient of x, which is 3. And our y-intercept value is going to be the thing that's added or subtracted. So that's 1. That means it crosses the y-axis at 1. So the order pair 0, 1 is the y-intercept. Okay? And we can now fill out the output values here. 1 times 3 is 3, plus 1 is 4. 2 times 3 is 6, plus 1 is 7. 3 times 3 is 9, plus 1 is 10. 4 times 3 is 12, plus 1 is 13. I want you guys to notice that when we think about the slope, right, it's easily detected and found by looking at the change in y over the change in x. Notice that from 4 to 7 is plus 3. From 1 to 2 is plus 1. The ratio of growth, the slope, is change in y over change in x, 3 over 1. That is your multiplier, 3. Notice it stays the same throughout the entire table. Every time you increase the output by 3, you increase the input by 1. Every time you increase the output by 3, you increase the input by 1. Right? That ratio stays the same throughout. So we know that that is our multiplier, 3. It's our slope. Okay, that's where the slope comes from. That's what it means. Okay, let's go to the next one. This one is a non-proportional, nonlinear function because it's an x squared function. So this one's literally just 1 times itself, 2 times itself, 3 times itself, 4 times itself. So 1 times itself is 1, 2 times itself is 4, 3 times itself is 9, and 4 times itself is 16. And this is an example of a non-proportional, nonlinear, because it doesn't have a constant rate, right? It's getting faster and faster function. And you can tell that it's nonlinear just by looking at the change in y over change in x. First, you're adding 3 every time you add 1 over here. Then you're adding 5 every time you're adding 1. Then you're adding 7 every time you're adding 1. In other words, it's getting faster and faster. The rate's not staying the same. Okay, so there's no slope on this one. The y-intercept, where does it cross the y-axis? That's just the value of y when x is 0. It happens to be 0 squared, which is 0, so it does cross the origin. This would be a y-intercept that is 0, 0. But we don't have to analyze it in that particular way at this moment. All you have to know is this is a non-proportional, nonlinear function. All right, let's look at the next one. The next one is y equals negative x squared plus 1. Once again, because of that exponent, you're noticing in both the last two we had exponents. those are going to be nonlinear. Remember, a linear function is in the form y equals mx plus b. The exponent on a linear function is always 1. If you have an exponent other than 1, it's going to be a nonlinear. It's going to be a curve of some kind. In this case, they're parabolas. So let's go through and figure out what this one would be. So this is going to be y equals negative the quantity of x squared plus 1. The thing you have to remember here when you're plugging in is that the exponent only directly applies to what it's touching. So that exponent raises the x value, okay, to an exponent of 2, but does not change the negative in front or anything with the addition, right? So really you're just doing 1 times itself, then get the opposite of that value, and then add 1. 2 times itself, then get the opposite of that value and add 1. 3 times itself, get the opposite of that value and add 1. 4 times itself, get the opposite of that value because you're really timesing it by negative 1, right? And then add 1. Okay? So that's kind of how we're going to do it. Let's fill it out. So what's 1 squared? 1. What's the opposite of that? Negative 1. What's negative 1 plus 1? That would be 0. And then what's 2 squared? 4. What's the opposite of 4? Negative 4. What's negative 4 plus 1? Negative 3. What's 3 squared? 9. What's the opposite of 9? Negative 9. Negative 9 plus 1? Negative 8. What's 4 squared? 16. What's the opposite of 16? Negative 16. Negative 16 plus 1? Negative 15. And so that would be kind of how you would plug into this particular one here. It would be negative 0, negative 3, negative 8, and then negative 15. Okay, and when we describe it, it would be a non-proportional nonlinear function. So a non-proportional because it doesn't have the same ratio of y over x throughout. Nonlinear because it doesn't have a constant rate. And it's still a function, though, because for every x, there is, in fact, only one y, right? Every time you put a 1 in, you're going to get a 0 out. There's no situation where you put a 1 in and get something else out. You always are going to get a 0 out every time you put a 1 in because that rule is being applied in such a way that there's only one output for every input. All right, let's take a look at the next one. This is y equals 1 half x. Timesing by 1 half is the same as basically dividing by 2. So all you're going to really do here is just cut these x values in half. So 1, 2, 3, and 4, pretty easy, right? This is in the form y equals kx. So this is a proportional linear function when x is 0, y is 0, and it has a constant rate of 1 half. So basically a slope of 1 half. As you increase x by 1, you increase y by 1 half. So this is what we call a proportional linear function. Proportional linear function. And the slope, if you wanted to explain what that slope is in fact 1 half. Positive 1 half is the slope. As x increases by 1, y increases by 1 half. This next one is in the form y equals mx plus b. So if we look at it, we can see kind of what the different components are. So we can see very clearly that the slope is going to be the m value, which is negative 3, and that the y-intercept is the b value, and that's 6. So this has a slope of negative 3 and a y-intercept of 0, 6. Okay, and so basically what this means is as x increases by 1, y isn't increasing, y is actually decreasing by 3. So every time the x goes up by 1, the y goes down by 3. So this line is going to be going down from left to right. You visualize it. And let's just plug it in and solve. What is it going to be? So this is going to be 1 times negative 3, which is negative 3. Negative 3 plus 6 is going to be 3. 2 times negative 3 is negative 6. Negative 6 plus 6 is 0. 3 times negative 3 is going to be negative 9. Negative 9 plus 6 is negative 3. And then 4 times negative 3 is negative 12. Negative 12 plus 6 is negative 6. So we can describe this as a non-proportional because it doesn't go through the origin. It crosses at 0, 6. But still linear because it has a constant rate, and the rate of growth is actually a rate of decrease, right? Where it goes down by 3 every time it increases by 1. To the right by 1. So to the right 1, down 3. So this is a linear function with a constant rate. The slope is always going to be negative 3. And it's still a function because, as we talked about, for every x, there's only one y. Every time you put a 1 in, you're going to get a 3 out. So the slope of this particular linear function is negative 3. And the y-intercept for this particular linear function is the value of 0, 6. Okay, and that is your y-intercept. Let's go down to the next one. This is once again y equals mx plus b. This is a linear function in slope-intercept form. So we can analyze it once again, a little color coding. So you got your slope, 5. You got your y-intercept, which is going to be 2. So basically this is going up from left to right. Every time x increases by 1, y increases by 5. and it crosses the y-axis at 0, 2, 2 up from the origin, right? So we pushed up by 2 units. Let's just do our multiplication before we add. So let's do 5 times the input and then add 2. So 1 times 5 is 5 plus 2 is 7. 2 times 5 is 10 plus 2 is 12. 3 times 5 is 15 plus 2 is 17. 4 times 5 is 20 plus 2 is 22. And we can see exactly where the slope is, right? Slope is that 5 value, because every time the output is increased by 5, the input is increased by 1. That is your slope ratio, right? That the slope is the change in y over the change in x. We can see that that's 5 over 1, and it's going to be consistent throughout the entire relationship. 5 over 1 is the same as 5 over 1 is the same as 5 over 1, and so on and so forth. Every time the x is increased by 1, the y is increased by 5. We can describe this one as a non-proportional because it doesn't go through the origin and the ratio of y over x is not always the same. But still linear. Why? Because it has a constant rate. The slope is constant at 5. Every time x is increased by 1, y is increased by 5. And it is still a function. Why is it a function? Because for every x, there is only one y. Every time you put a 1 in, you're always going to get a 7 out. There's no situation where you put a 1 in and get something different than a 7. So it's a function. And the slope of this function, as we discussed, is 5. And the y-intercept of this function is going to be the order pair 0, 2. In other words, it crosses the y-axis at 2. And last but not least, we have a y equals kx proportional relationship here. So hopefully you guys are recognizing all these different functions by now. This one's going to be a proportional linear function because it does go through the origin and the ratio is always staying the same. And if we were to plug in to find out what the outputs are, you literally just multiply by 3. So 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, and 4 times 3 is 12. And we know that the slope of this particular proportional relationship is going to be the multiplier, so 3 in this case. So the slope is 3, because basically as the x increases by 1, the y will be increasing by 3. This is a line that would be going up from left to right and be pretty steep. So now you hopefully can feel comfortable analyzing all these different types of functions.